welcome everybody. In today's talk, we're going to discuss some topics on AI, artificial intelligence, and how AI is affecting the cybersecurity, and how Hillstone Network is doing and investing and working in AI and the machine learning areas. The AI is a very large topic, so one person can spend the entire career working on just one aspect of AI. And one company, one enterprise can spend the entire business just to bring up one or two AI products. And also AI itself can form entire industry sectors. So it's impossible to cover all the aspects of AI, even on the surface in a short period of time. So today, we are just going to go over some of the general information of AI, and also some of the aspects of AI with regard to the cybersecurity, and also discuss some of the works where Hillstone Networks is doing in AI and the machine learning areas. So if you have any questions, feel free to write in the chat window, or at the end of the presentation, I'll be happy to answer the questions and discuss with you. So what is AI? AI is hot these days. It's a hot buzzword. Everybody's talking about artificial intelligence these days. Everybody is actually doing it these days. And many companies are coming out with AI-driven security product. For example, Palo Alto Networks recently announced the PenOS 10.0, which is a machine learning-driven next-generation firewall. And also we see many other companies coming up with the AI-driven security product and solutions. So AI is everything, everywhere. Everybody's talking about it. Every company, most of the companies is doing it. These days, seems if you're not doing something related to the AI or machine learning in the cybersecurity space, basically it looks like you are out of date or out of the loop. AI is becoming more sexier these days. So AI is really hot. AI actually is really changing everything security companies is doing in the cybersecurity world. So in this talk, we'll go over some of the basic aspects of AI, artificial intelligence. And also, again, we're going to briefly touch some of the artificial intelligence-driven security solutions and security products from Hillstone Networks. AI really is changing everything, cybersecurity, how cybersecurity defense companies are doing these days. On the other hand, AI also can be a double-edged sword. It can be good if it's used properly, and it can also have a negative impact if not using or doing properly. So why we need AI these days, artificial intelligence these days? Let's from higher level, cybersecurity is facing greater challenges these days from several reasons, for several factors. First, we are facing actually more sophisticated, targeted, and often state-sponsored attacks, cyber attacks these days, compared with previously some more amateur or ad hoc attacks using some conventional or even lower level skilled attacking tools. These days, the attacks are more sophisticated, more complex. For example, we see more often attackers using the social media platform doing the phishing attacks. With all the cell phones and mobile users, we see more malware attacks from the mobile devices. And also from the website, we see more sophisticated web-based attacks. And also we all know that these days more and more ransomware are coming up to the ransomware attacks. And recently, because of the election year or for political reason, we see what we call the deep fake, which is a mechanism used by the attackers to put all these links or hidden phishing type of things in the video to make it more authentic. Actually, it was either fake or some other malicious purposes for political gains or political campaign oriented. So we call deep fakes these days. So attacks have become more sophisticated these days. The other hand is with the cloud adoptions, more and more business are moving, enterprises are moving their business to the cloud. The cloud adoptions have increased cybersecurity complexity and open up the whole domain for cyber attacks and cyber defenses. So with the cloud, usually the cloud access is more important. And with all these easy to misconfigured and with the human errors involved, with the weak, for example, weak credentials, all these factors involved. So hackers or attackers are more easier to penetrate the cloud-based infrastructure. And also inside the cloud, more and more applications or services are using micro-based services, either on the virtual machines or on the containers. So the scale of these applications or services on these containers, scale is a number of these containers or VM used on a very large scales. So it's difficult to gain visibilities between the east-west type of traffic, east-west type of events. So it's more and more difficult to gain visibilities and oversight. So this also increased the difficulty levels of the cybersecurity inside the cloud space. And also with the adoption of 5G and IoTs, and edge computings, we see more and more wider attacking surfaces. So it's also imposed more challenges to cybersecurities. So in this case, cybersecurity demand is very high because any severe security breaches are very costly, either financial costs, financial damages to the organizations, or cause business disruptions, or for the consumer brand, it can cause brand reputation damages, and for the consumer users, we can cause also personal data leakage, so cause the security to the personal informations. So all these security breaches, once it happens, is very costly to the companies and to the organizations and also to the individuals. So as a result, we see more and more regulations and laws require stronger security compliances. And for example, to name a few, we have the federal cybersecurity law, we have the state-specific regulations. We have in Europe, we have a GDPR. I believe in other parts of the Asian countries, we also have a similar laws to protect the privacy and the data privacies and the consumer privacies and protect the data leakage, things like that. So the demand here for cybersecurity become higher and higher and stronger and stronger. And the penalty for these data breaches has become more and more severe. On the other hand, the cybersecurity these days become more and more complex. This is because several main factors, to name a few. Number one is network boundaries are blurred these days compared with before, or sometimes even vanished with the adoption of the cloud computing. For example, more and more people get into the network from mobile devices, from end user endpoints. So basically, the network boundaries has been extended from the corporate border all the way to the end user devices. Especially with this pandemics, people work from home. So they are more and more, the network boundaries have become more and more wide, or sometimes even vanished. So this also opened up attacking more and more wider attacking surfaces and make the cyber detections more and more difficult. Also, with all these IoT devices, with the mobile devices, with the adoption, with the emergence of 5G networks, so the attacking surfaces have become wider. And also, the attackers these days are using more and more invasive and sophisticated techniques and tools compared with before. So these are very easy. They are very easy to penetrate the network defense at the perimeters. And also, very often, the legacy security defense mechanisms are no longer useful or no longer effective. So in this case, some new mechanism has to be used, new technologies have to be developed in order to protect the network and user data more effectively. And one of the most important things here is factor for the network security complexity is with the data explosions, we see more and more data from all kinds of devices, all kinds of applications emerged. And these data within the protective networks have to be collected, monitored, analyzed. So this usually overwhelms any human abilities to conduct any effective security analytic jobs. So this also demand we need some more intelligent ways to handle these daunting tasks. So AI, now we talk about artificial intelligence. So what is actually the AI, artificial intelligence? There are many different definitions according to different organizations, different people, but they all are similar. So AI is basically using tools or a process to make computers to think or process like a human being. So this is what AI is. It's a set of tools or process or algorithm, in this case we can call, to make the computers do things, think things, and process stuffs like a human being. AI actually is a umbrella for a set of technologies. We heard about machine learning, we heard about the natural language processing, computer visions, neural networks, deep learnings. All these all collectively can be put under the AI umbrella. So AI actually is not something new. It's been there for a long time, even can date back hundreds of years. But modern AI, commonly people agree, start with since 1950s, when the Turing test was invented to use to measure whether a computer can think like a human being. A set of test cases. Let's start from 1950, I guess. 1960, we see the origin of machine learning, the basic machine learnings, and also after like 1980s or 1990s, we see more mature machine learning techniques and also deep learning. 1990s and year 2000. After year 2000, we see deep learnings and also more and more complex AI algorithm emerged. So actually, AI is reaching. I think AI is reaching its critical mass these days. 10 or 20 years ago, when people go to colleges, the colleges already offered AI courses. Actually, usually in the graduate school, people can study computer visions, artificial intelligence, neural networks, and also they can do the research project in the lab, and without any industrial or commercial usage. Mostly is for the research process purposes in the lab, and usually they are operating on the limited data sets and using these algorithms for some master degrees or PhDs, for some dissertations, for some research purposes. But now, with a faster internet access, with more applications available, with more use cases available, more and more data and information are available too. And these data is the key, is what was the driving force for the AI, artificial intelligence. Just because we have more and more data for more and more applications, AI has reached its critical mass and showing the best these days. So what are some of the building blocks in artificial intelligence? Number one is, first of all, we need to define the mission, what we want to do, what target we try to achieve, what problem we try to solve. So this is number one thing. We're not doing AI just for the sake of AI. We need to have a goal. We need to have a target. Like, for example, in the network security, we try to detect unknown malware. We try to detect encryption channel, data channel. or we try to model some behavior to detect the abnormal behavior. So we need to have a goal or target or mission. So this is number one to be considered when you try to use AI. Next is we have data. We need to collect all the data, relevant data. Usually data, we have a lot of data, lots of data. Some of them are structured data. Some of them are unstructured data. We have lots and lots of data. So we need to collect them and pre-process them, normalize them, and store them, all these data, in order for AI to conduct AI activities. So basically, we make this data ready for AI operations. This is called data processing. And next is after data is pre-processed, we do the modeling. Prior to the modeling, we need to do the data mining. Data mining is basically we need to extract features, what we call the features, from these data to conduct modeling and also train this model, build this model, train them. And after that, we can run these models either in the cloud or on the security devices. So this mission definition, data processing, and modeling are the key elements of AI building blocks. Now, after the model is run, we need to output. We need to give the insight of the result. And also we need to provide some knowledge base and provide some actions on these outputs. And the other very important factor is the lifecycle management. So the model itself, usually the company will put these models on the physical device. And physical device have a limited computing capacities or system resources capacities limitations. So we need to usually what practice is companies put these models on the devices and also at the same time in collaboration with the cloud. The model usually are trained, data are usually collected to the cloud, and the model keep training, keep updating to the device. So this is the closing, there's a loop. So life cycle management is also a very important factor in the AI building blocks. So what are some of the benefits of AI? We said already, right now we have tons of data, lots of data to be analyzed. So in this case, it's impossible to conduct these works manually, even automatically, it's impossible to do. So AI here shows its best capabilities. AI will help to automate the security analytics process. So that's what the AI is best in doing these type of jobs. Also, AI using modeling, AI is best to be used to detect the unknown threats. So known threats usually can be detected using static signature-based mechanism. But AI is best is model the behavior analysis, behaviors, and model these conduct dynamic analysis. This is the best to detect the zero-day attacks and unknown threat attacks. So this is what AI can help. Basically, it can help to automate the security analysis process, and using model, we can help to detect the unknown threats. And also, it can help to accelerate the threat response. So once the threat is detected, we can using a machine learning or AI mechanism to conduct the threat hunting and forensic evidencing, and then also conduct the automated incident response process. So AI can help in these aspects of the security works. What are some of the side effects of AI if not used properly? We know that for legacy security device, for policies and for the IPS, for example, signature-based mechanism, the result is always 0 or 1. Whether you drop the packet, whether you let it go, whether this a DNS name, domain name is benign or is malicious. In this case, we say it's black or white. So traditionally, we get this
0 or 1 type of decisions from traditional security devices. So it's very clear, no ambiguity, even though it's wrong, but it's no ambiguity. But with the AI here, we are doing this through modeling, through behavior analysis. So we now have a range, not 0 to or 1, but we have a 0 to 1. So there are many possibilities involved here. Whether this domain name looks like it's malicious, looks like it's not good, but we're not sure. So usually we give them some confidence level, confidence index, or we call the risk or some score to represent how confident we are in determining that this result is really true or not. So from 0 or 1 or 0 to 1 is a big step for the security devices. So as a result, if the AI algorithm is not good, if it's inferior, it will increase ambiguity to the users. User will get confused whether this is really good or really bad, or what decision to take based upon the output. And even worse, sometimes it causes what we call false positives. False positive is a very bad thing because it prevents the security analysts, the security admins, to make a sound and clear decisions. So if you have many false positives, the user basically will turn it off. We're not going to use your solutions or algorithms. We see this in early adoption of AI before. So as we improve the AI models, the AI algorithms, we can reduce false positive further and further until it's very close to realities and where it can be useful by the users. So we need a good AI algorithm, a good AI model for AI to be really useful. The other aspect is the hackers can also leverage the AI algorithm to make the attack mechanism, attack tactics more sophisticated and more invasive and more hidden to bypass or to escape the detections. So use AI can be both a double-edged sword, for both the security defenders and for the hackers. So we need to use them effectively, in high quality, use them wisely. What are some of the good artificial intelligence-based solutions? At least some of the criteria here, some of the points here I thought. The number one is AI should be explainable. So we developed a model. So we need to convince the user that the model is good. So we need to let the user know to the maximum extent. Maybe they don't understand completely, but we need to explain them in plain English, the human languages, how this works, how this is supposed to work, instead of treating them like a black box. So user has to be able to understand the modeling process and understand the outcome of the model. So this is what we call the UI. The AI should be explainable to the user. The other thing is the UI AI should be tunable. It's not a box that model we set it and forget about it. So the model itself should be upgradable. The parameter of the model should be tunable. So make it more and more optimized. And the other aspect is AI results should be actionable. So we can use AI results usually in the devices or in conjunction with the security devices to use these results to mitigate the attacks or mitigate the damages. The other, one of the most important things, they need to have a cloud collaborations. Without the cloud, we cannot say we have AI solution. So we only have part of it, just like a cache, just like computer cache on the device. AI needs a cloud to keep training the model, keep updating the model. So cloud collaboration is actually critical here. So Hillstone networks have a very large and diverse security appliance and security solutions. And we have a large customer installation base, which means we can collect data from all the devices, from all the customers, given they are permitted to. So it's easier, it's enable us to conduct the modeling at the back end. So there are many security devices or security products or security solutions from Hillstone that have a machine learning model or machine learning detection engines inside. Hillstone AI's journey have several features, several characteristics. Number one is we are use case driven. We are trying to resolve some of the customer problems. We're trying to resolve some of the most difficult customer problems. And all these AI and more machine learning engines are very purposely built instead of a general AI or machine learning engines. They're very purposely built to target a specific problem or specific attacks to attack detections. So we are user case driven, and the engine themselves are usually very often purposely built. So the machine learning driven security product from Hillstone Networks are used in these areas. First is we have this, we've been used to detect web-based attacks. Second is we are doing this for the signature optimizations. So basically we have the machine learning model in the cloud to keep optimize the security the signatures, for example, IPS signatures, and we keep updating the device to the optimized signature. And also we're used to for DNS security. For example, machine learning model can be used to detect the DGA domains or detect the malicious DNS channels, tunnels. The other aspect is we use machine learning for threat intelligence analysis in the cloud, and also some other aspects for malware detections or malware analysis. So again, in the Hillstone's AI-driven security products are use case-driven, purposely built, and cover all aspects of the security defenses. And also we have the device and cloud collaboration to close the loop. So here are some of the list of the Hillstone Networks AI-based security product portfolios. A few years ago, we invented what we called intelligent next generation firewall, ING firewalls. This basically used the machine learning models inside the device to conduct the traffic analysis. Now it's called NDR, Network Detection and Response by Gartner. And also we have these engines to conduct the DNS securities. And also we have the machine learning engine for the web attack detections. And also we have the machine learning engine inside the box to conduct the threat event correlation analysis. So this product actually was introduced a couple of years ago, and it was on the Gartner's Magic Quadrant for NG firewall for many years. And also in 2017, it won some award, the best of the breed award or something for this product. And the other security product from Hillstone Networks has a lot of machine learning elements inside. Is what we call the server breach detection system, the SBDS. So this SBDS also have a lot of machine learning driven detection engines inside the box. So it can conduct the traffic analysis, conduct the behavior analysis, and also integrate with other threat intelligence platforms to protect the critical servers. And these products also, for 2 years, continuously been named Gartner's NDR recommended vendor in its market research guide. And also separately, he won some award at RSA conference, the innovation award, some award like that. So other machine learning driven security products include Hillstone's threat intelligence platform, TIP. So these are contains machine learning engines inside the cloud to conduct threat analysis and update the latest threat intelligence to the devices. The other product we have, what we call Security Operation Platform, SOP, product name called iSource. iSource is basically a big data analytical platform that consists of multiple traffic sensors and threat sensors. And these sensors collect the information, traffic information, collect the threat detection information, and send to the center platform for analysis on a global base in a distributed and scalable manners. So these also have a lot of machine learning engines inside this central analytical platform to conduct the analysis on a global base. And the other aspect I talked earlier, we have the cloud-based machine learning engines to conduct the signature optimizations and signature update to the devices. So Hillstone networks have a rich set of security product portfolio that utilize AI and machine learning mechanism. So what are the future of the artificial intelligence in cybersecurity? Here I quoted some of the data from some magazines. They said 60% of the security professionals believe without AI, it is basically impossible to detect future attacks. This is very true. As I mentioned earlier, AI is best at detecting the unknown or zero-day attacks because it's used to model the behaviors and can model based upon the existing malware samples, to model the mutations, model the changes of the malware. So this can be used to detect the future unknown attacks. And also, over 60% of executive level security analysts says that AI has greatly reduced the cost, either to discover our vulnerabilities or to help to investigate the vulnerabilities. So these executive level security analysts believe AI has greatly helped to reduce the cost to do these jobs, which is also very true because we have a lot of data to analyze. So AI helped to automate these processes to liberate all these security admins and security analysts from the labor-intensive work, so they can focus on more higher priority analytical works. And also on a global base, they said more than 73% of the company have already started testing AI use cases in the cybersecurity. Basically, I know every security company or security solution providers are using some sort of AI or machine learning driven techniques inside the product or inside the solutions. So this is how AI can help in the cybersecurity, and this is what I believe the future trend. AI is here, and everybody is doing it. So, but we need to do it properly. We need to do it correctly in order for it to be more effective.